Hi there, this video is going to be talking about how to assign oxidation numbers first, and then I'm going to assign which particular atom is oxidized and which is reduced. Well, this is the back of your practice problem, so we'll take them step by step. If you have to skip to the next problem, go for it. Just fast forward until you get to the part that you need help on. Here we go. First thing I'm going to do is assign oxidation numbers. I'm going to look at Na. Na, I can see he's not connected to anybody. He's all alone, single element, no charge on there. His oxidation number is 0. Li is an ionic compound, so here's when we'll go looking for its ion charge. I like to look for negative guys first, the Cl. I look and I find Cl right here. This is a 0, a -1, -2, -3, so chlorine is a -1. -1. Which means lithium, in order to balance out, has to be a +1, but I can always double check that by looking at lithium. He's right here. +1 column, +2, this one right here is a +3. So yes, lithium is a +1. Going on to the next one. Lithium is all by himself, nothing around him. His oxidation number is 0. NaCl, once again, I like to go to the negative. Cl is a -1, which means Na has to be that +1. And I can double check that by looking and seeing that Na is down that +1 column also. Okay, now my next step is to decide who's oxidized and who's reduced. And the whole purpose of this is to decide how the electrons are transferring, who is losing electrons and who's gaining electrons. Eventually we're going to use that information to create electricity. So I have to look for who changes oxidation numbers on both sides. For example, Na has a 0 on this side, but Na has a +1 on this side. He's changed. The other thing that changed was Li is a +1 on this side, but now he's a 0 on the other side. He's also changed. If you look at chlorine, he's a -1 on one side and -1 on the other. He hasn't changed, so he's not oxidized nor reduced. Now I'm going to take a moment and see how the numbers changed. Na went from a 0 to a +1. The only way to become positive is if you lose negative stuff. Losing negative stuff means you lost electrons. Na has lost electrons. Lose electrons oxidized. The thing that's oxidized in this case is Na. On the other part, I'm looking at lithium went from a +1 to a 0. The only way to go from a positive to a 0 is if you gain negative stuff. Gain electrons. Gaining electrons would mean you're reduced. Lithium was reduced. Oxidize is lose, reduction is gain. Or lose electrons oxidized, gain electrons reduced. Whichever mnemonic device you like. Going on to the next one. This one gets a little bit trickier. Here I've got Fe, and he's attached to SO4. Like I said, I like to do the minus guys first. Taking a look at SO4, that's a whole polyatomic ion. So you can't just look up S or O. You've got to look on the back of your polyatomic ion sheet. That's the back of your periodic table, and I see sulfates right here. SO4 is worth a -2. That means this whole thing right here is worth a -2. Which means on the other side, my iron has to be worth a +2. Iron is kind of tricky actually, because if you look for iron on the periodic table, he's in the middle here, which means you don't know his charge. If you find him in the middle, you have to go to the back of your periodic table. In the middle of the back of your periodic table, you'll find iron. And you'll see iron is listed as a +2 or a +3. So you really don't know unless you look at the negative guy, which I did, SO4. Now I'm going to take a look at SO4 and look at its pieces. Oxygen is always that -2. Boom, I put them on there. -2 times the 4 gets me a total of a -8. Now this whole sulfate thing has to be worth a -2. So 8 plus 6, 8. 6 minus 2 gets me a total of that -2. And if I add it all up, it adds up to 0, which is what I'm going for. Okay, going on to the next guy. Here's magnesium. He's all by himself. Oxidation number of 0. Going to the other side, I see magnesium is now hooked up with somebody, so he's going to have a charge. Like I said, normally I like to go negative guys, but I'm going to look at magnesium here, because normally he's a +2. So that kind of makes my life a little easier, +2. Sulfate, that means, right here, has to be worth a -2, and I know that's true. I looked at the back of the polyatomic ion sheet. Oxygen's a -2. 2 times the 4 gets me a -8. That means sulfur has to be a 6. 6 minus 8 would add up to a -2. So sulfur is a +6. And then last but not least, I've got iron. He's all by himself. He's a 0. My next step is to once again check out who's changing electrons from one side to the other. Or in other words, who's changing oxidation numbers from one side to the other. A big key part is to kind of look for those zeros. That kind of helps things out a little bit. I'm going to see iron went from a +2. And on this side, he's at a 0. +2, going to a 0. The only way to do that is if you gain negative stuff. You're gaining electrons. In this case, the thing that was reduced was iron. Gain electrons reduced. Check out the other guy that changed from side to side. Sulfate's the same on both sides, so I want to look at this magnesium. He went from a 0 to a +2. The only way for that to happen, a 0 to a +2, is if you lose negative stuff. You lost electrons. Lose electrons is oxidized. Magnesium is oxidized. Alright, I'm going to my last one down here. Erase it. That should work. That's okay. Okay, so now I'm going to assign oxidation numbers. Calcium, this is calcium carbide. Calcium happens to have a +2. Calcium is right here in this second bunch. He's a +2. Carbon, in this case, seems a little bit funny. Like, what could carbon be then? Well, calcium is a +2. And carbon has to be worth a -2 then. That means each carbon is worth a -1. This one is a weird one. You're right. It's tricky. Going to the next part. I've got H2O. H is a +1. Oxygen's a -2. I always put those down every time. Looking at the numbers, -2. This side is worth a +2. Yes, they balance out. Remember, this 2 right here, it actually doesn't matter at all. It doesn't change the oxidation numbers. It just means that you happen to have 4 hydrogens and 2 oxygens, but it really doesn't affect your oxidation numbers at all, so you can kind of disregard or not really look at those. Going to the next side, I've got calcium over here. Calcium's a +2, it's part of my compound. H is a +1, O is a -2, pretty much every single time, so now I'm going to double check to make sure it works out. Calcium being a +2, I happen to have 2 of those oxygens, so that's a total of a -4 right there. And this right here, 2 hydrogens, gives me a +2. That means if I add all that up, +2 minus 4, +2 gives me a 0. This balanced out and worked out. On to my last part. Hydrogen's a +1. So then I'm going to look a little more carefully, and I can see hydrogen being a +1. Carbon, this makes a +2 total. Carbon on the other side has to be worth a -2, which means carbon's worth a -1 here. Things are looking pretty good so far. I got to decide who's oxidized and who's reduced. Check out both sides. Calcium's a +2, calcium's a +2. They didn't change. Carbon's a -1, carbon's a -1. They didn't change. Hydrogen's a +1, hydrogen's a +1. They didn't change. Oxygen's a -2, oxygen's a -2. They didn't change. This is a double replacement reaction. This is not a redox reaction. Not a redox reaction. Nobody has transferred electrons. Nobody lost electrons. Nobody gained electrons. It is not a redox reaction.